Hi, this is Mrs. Roble. So what I need you to do is I need you to follow along with me using the notes that I submitted with you, and these notes are going to help you to finish your missing homework and take your quiz that you missed. So notice that we are now talking about what we call the octet rule, and most elements on the periodic table follow this. However, there are two elements that do not. That is hydrogen and helium. They only want 2 valence electrons, so they do not want to have 8 electrons as their outer electrons. Notice that in order to have 8, the the elements want to have full s and p orbitals. So the s is the first 2 columns in the periodic table. The p are the last 6 columns in the periodic table. And that's where the valence electrons reside for those elements. Now, in order for an element to have 8 electrons, it has to do something interesting. It has to either add electrons, give electrons, or share electrons. So when atoms do that, they actually create a bond, and we're going to be looking at what kind of bonds there are. Okay, so as I mentioned before, these are the s electrons, and these are the p electrons, and these are the outer electrons that atoms will either give, take, or share in order to get 8 valence electrons. Now, what I would recommend is with this little chart here, I would copy it and paste it into the document that you're going to complete for your homework. It's very useful. Now, when you take a test or a quiz, you're not going to have access to these oxidation numbers, so please remember that you probably want to memorize these oxidation numbers. Now, the only exception I would argue is carbon. Carbon is one of those weird ones where it actually will either lose electrons or gain electrons. So most of the time we just care about the 1 plus, 2 plus, 3 plus categories, and then the 3 minus, 2 minus, 1 minus categories. Notice that in this column here, which is the noble gases, most of the time these atoms do not bond. They already have a full octet, and they are not interested in gaining, losing, or sharing electrons. Okay, so we are actually going to look at the Bohr model to help us understand why atoms bond. Now this table is really important, and some of the future work that you're going to be doing, you want to keep track of what is ionic versus what is covalent versus what is metallic. Notice that with ionic, we are talking about a metal, and this metal is actually reacting with a nonmetal. So the way we identify ionic compounds is we look for the presence of a metal, and notice in this example here below, lithium is a metal, and notice that it's transferring electrons to fluorine. I would remember that metals always tend to give away their electrons. So you're always going to have a positive charge with the metal, and you're going to have a negative charge with the nonmetal. Now, this past week, whether or not you were available for class or not, we talked about covalent. Now notice that covalent is different. Covalent, we are actually talking about 2 elements, and they are both nonmetals. And the interesting thing that happens with these 2 nonmetals is they actually share electrons. So we want to represent their bond differently than we do ionic. Okay, and the last type of bond is metallic. Metallic is one of those weird ones where the electrons are actually flowing between the metal atoms. And notice that in order to identify a metallic bond, we need to have two metals, and they are freely sharing those electrons between them. Okay, so this is to help you with your homework that you're going to have to be doing in the near future. And like I said, if you want to copy that oxidation chart that was listed earlier, you are welcome to do so. So the first thing you want to do is you want to draw the Lewis dot diagrams for the neutral atoms. And if you look at potassium, potassium has one valence electron because it is from the first column of the periodic table. So it has one electron, and we typically draw that with a dot. Now fluorine is actually the second to last column, which is the halogens, and it has 7 valence electrons. So how I want to represent that is I want to show 7 dots. Now if you notice, there's an empty spot here. And this empty spot is where this electron from potassium is going to flow. Now we have to show the transfer of electrons, so we have to show the fact that potassium, which was neutral, is no longer neutral when it gives up that valence electron. So we're going to put potassium in brackets, and we're going to show the fact that it lost one electron. So it still has its protons, and as a result of it, it has a positive charge because it lost the negative electron. Now fluorine has the opposite. It actually gained an electron. So as a result of it, with its remaining protons, that additional electron is actually giving it a negative charge. So as a result, fluorine has a negative charge. Now together they form what we call an ionic bond. So in your homework, I need you to show me how this happens. Alright, I'm going to do one more example here, and then I'm going to set you loose on your homework. So notice that calcium is from the second column of the periodic table, and as a result of it, it has 2 valence electrons. And as we saw with the previous example, fluorine has 7. So fluorine has only room for 1 valence electron. And there's a problem, because when calcium tries to donate its valence electron, there's only 1 fluorine. So guess what? We have to add another element, and the element that we're going to add is a second fluorine. So when we do that, we're allowing the second remaining valence electron from calcium to come and be transferred to the second fluorine. So notice that there's a inequity, and as a result, we need to conserve mass because 2 electrons have to transfer from somewhere. So when you draw your new ions, once again, calcium is a metal. It's losing electrons. It has a remaining positive charge, so as a result, we are losing 2 electrons, so we're losing 2 negative charges to give us an overall positive charge. Fluorine has the opposite. So fluorine gained an electron. Remember, it has a remaining positive charge, but that additional negative charge makes it an overall negative charge. And we can't just draw one of these. We actually have to draw 2 of these because we have a second fluorine. Oops, sorry guys. We have a second fluorine that is being added to this compound. So as a result, our formula, instead of it being CAF, it's actually CAF2, which reminds me, I forgot to write this up here for the formula. This is KF for the formula. By the way, I think I should just reiterate naming. So when you have an ionic compound, the first element says its name, which is potassium. The second element changes its ending. So instead of fluorine, this becomes fluoride. So KF is potassium fluoride. And notice there's a U before the O. Make sure you spell it right. And then lastly here, when you name it, the first element says its name, which is calcium. And then once again, the second element changes its ending to calcium fluoride. And do not try to add any prefixes to that, even though there's 2 fluorines there. All right, so make sure you complete your assignment, and I will get back to you with corrections.